Why does an electron emit light when it hops from one energy level to another instead of just quietly changing its state? Textbooks usually say one short sentence: the energy difference is released as a photon, which sounds neat but never tells you two crucial things: what light actually is, and why the bill for the energy difference has to be settled in the form of light at all. In the energy filament theory, this process becomes very concrete. Emitting light is simply what happens when an electron changes orbit and throws its leftovers or missing rhythms into the energy sea. That dumped rhythm is shaken into a tiny traveling wave packet that we recognize as light. Start from the orbits themselves. In earlier episodes, we said an electron's orbit is where the smoothest path is. Two different slopes cancel out the inward static slope from straight electric textures and the sideways spiral slope from spin, magnetic moment, and phase. Where these two slopes balance, the electron finds a track that is easiest to follow. And that tracking is what we call an energy level. Each such orbit is not just a geometric loop but a fixed way of keeping time while going around the nucleus. Like a dance pattern with a specific number of beats per circuit. Some are slow and loose, some tight and fast. And in this language, the tightness of the beat is what we mean by higher or lower energy. Now picture an electron that wants to move from one orbit to another. Jumping from an outer orbit down to a closer one means switching from a looser rhythm to a tighter one, while jumping outward means going from a faster beat to a slower one. There is a strict catch. As the electron travels around the nucleus, its internal rhythm has to close on itself so that when it returns to the starting point, the pattern lines up exactly, like the hands of a clock landing cleanly back on the hour mark instead of stopping half a tick off. If the rhythm fails to close, the spiral textures no longer mesh with the nucleus and the surrounding sea, and the orbit stops being a smooth path. That makes the jump between levels a timing problem. On its current orbit, the electron is running one number of beats per loop. On the new orbit, it must run a different number. And there is no way to have to both at once. You cannot spend half a circuit dancing to the old beat and half to the new and still come back in phase with either. So in the instant of the jump, the electron has to get rid of, or borrow, a very specific amount of timing difference. The exact surplus or deficit of beats between the two closed rhythms. You can think of it like a dancer who wants to fall into step with a new song. Before they can lock to the new beat, they need to let go of the extra taps or missing taps that belong to the old ones. When the electron does this, the discarded or borrowed timing does not vanish into nothing. The surrounding energy sea takes that little packet of beating errors and shakes it into a clean, traveling disturbance. A compact bundle of oscillations with a definite rhythm, frequency, and direction. That bundle is what we call light. It is not a hard little marble and not just an abstract number. It is a piece of timing difference marching through the energy sea as a filament wave packet. If the electron jumps from a lower level up to a higher one, it needs extra beats. It is like stepping from a slow dance into a faster one. In that case, the sea must supply a matching packet of rhythm, so an incoming wave packet is absorbed, and the electron uses its timing to close the new orbit. To us, this is absorption of light. If the electron jumps from a higher level down to a lower one, it is running too many beats for the new, lazier orbit, so it has to shed that surplus into the sea. The shedding rhythm becomes an outgoing wave packet, that is emission of light. So the real answer to why does a level jump emit light is not because the electron has some bookkeeping and photons are the currency. It is that the old orbit's closed rhythm and the new orbit's closed rhythm cannot be spliced directly together, and the difference between them must be handed off to the medium as a separate, traveling disturbance. That disturbance, once it leaves, is exactly a flash of light. Seen from this angle, light stops being a mysterious little messenger bouncing between levels and becomes more like a spoken sentence. Every spectral line is the electron telling the energy sea, I am switching rhythms, please carry away this exact leftover beat. The sea takes that sentence and releases it as a real wave moving through the universe, which is what our instruments record as sharp, colored lines in a spectrum. Tap follow, share it on New Physics, Clear Universe.